Mungkin Haris turn on camera ke what? Haris baru on camera. Haris, Muhammad Haris Rahim. Memang purposely ke apa on your camera? Turn on
Tertekan.
Oh, dia tekan bahasa Inggeris. Lain pula kan? Tekan ke stress ke apa? Okay.
Bukan.
Ah,
Turn on.
Okay, 34. Saya dah seru baru 34 students. Okay, section 9 please. Tomorrow petang 24. Section. Sebenarnya bila online ni.
Saya tak join, madam. Tak tahu.
Apa dia?
Saya tak boleh join. Sebab ada kelas etika.
Tak boleh join
Hmm.
So malam saya sebenarnya kan memang plan sana mula kita dah plan malam. Tetapi saya ni sungguh salah nak cakap. Rumah saya setakat ni kan non-stop orang datang. Aduh hai. Ada yang sampai pukul 1. Saya risau pula kan esok. Melainkan saya datang ke office lah. Malam. Tapi tak apalah. Tapi before that kita dah decide malam kan. Tak apa, kita run je malam. Kalau let's say tiba-tiba ada tamu datang tu, kita kelas tu sekejap je lah kan. Boleh kalau malam esok, okey. Sebab saya tak nak kacau kelas yang ada kelas.
Malam pukul berapa, madam? Sebab
8. Sebab apa?
6 sampai 8 ada exam, ada test.
Oh, mak kesiannya you all.
So 8 sampai 10 ya, madam? Kelas madam nak buat, cadang nak buat.
Saya bercadang macam tu lah, hopefully tak ada, sebab hari Khamis cuti. Saya takut macam aduh, takut ada ni kan. So far saya non-stop dapat tetamu. Tak apalah, kita try dulu. Try juga 8 hingga 10. Okey ke? Kalau tak selesa, just fine. Kita buat hari Wesak tak boleh. Khamis, Jumaat. Hari kalau Sabtu boleh. Weekend.
Boleh je, doktor.
Boleh je. Risau pula saya lah. Okay, Chan boleh. And then one more thing lah sebenarnya. Saya Sabtu, Ahad. Boleh tak angkat tangan siapa section 9? Sepatutnya section 9 ada 19 orang. Counting now. Okay. 15, 4 orang lagi tak ada. Okay, so nanti saya minta dia tengok recorded version lah. Ataupun you all petang ni, of course you ada kelas kan? That's why you pilih section 9. Betul tak?
Betul.
Okay, kalau macam tu, kita esok Wednesday, so Wednesday tomorrow, pukul 2 cannot, 2 PM cannot tomorrow. Either Wednesday malam esok 8 hingga 10 or pukul 8 hingga 10 ataupun hari Sabtu malam 8.10. Okey? Malam esok 8.10 okey?
Okey je.
Okey je. Sebab I hope that hari Khamis tu kan ramai orang balik kampung, hari Sabtu tu mungkin orang kepenatan lah. So mungkin tak ada tamu lah kan. Kalau malam esok tiba-tiba ada tetamu, we have to decide to arrange at the time. Okay, so that we decide that for section 9 tomorrow. Ada apa nak cakap ke? Oh, Ashraf 8.10 ada test
Ya,
So
madam.
still cannot. Sebab saya tak boleh langkau selepas hari Ahad. Ahad pagi, you all available tak? Kalau Sabtu tu saya takut jugalah Kalau tiba-tiba, kalau hari bekerja, saya kena settlekan perkara ni. Sebab, for your information, 8 hari bulan, antara 7, 8 ataupun 8, 9, okay, saya need to travel out of Batu Pahat. Saya kena pergi tempat yang no internet connection. So kalau 9 hari bulan saya kena 8 dengan 9, so that saya tak boleh ada kelas. Kalau kata ada kelas pun, saya tak boleh buat kelas sebab section 9 masih belum ganti. Ahad pagi ada kelas tak? Section 9. Pagi-pagi ke pukul 8?
Saya ada kelas.
Oh, rajin pula kelas awal pagi Okay, so that kita stick with Sabtu malam 8.10.
Boleh, madam.
Sabtu
Boleh, madam. Boleh.
Sabtu berapa hari bulan
Boleh.
Okay, Sabtu Khamis 4, 5, 6 6 Mei kelas ganti section 9. Siapa tak boleh kena beritahu terus tau. Alright. Saya count up to 10 kalau no issue, and then kita confirm with Sabtu lah. On Saturday 6 May 8 to 10 PM. Okay? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So our class, replacement class for section 9 will be on 6 May, Saturday, 8 to 10 PM. Okay, thank you everyone for your cooperation. So that we continue. There is a question from Chan before this about A and B yang about guna case pertama kan, yang akan ada guna Kosh tu, Shin and Kosh, coordinators said that tak kisah A and B tu bertukar, sepatutnya dia akan dapat jawapan yang sama juga if you use exponential tu. Okay. Cuma we haven't try kan for any question. So sepatutnya no issue. Okay Chan? Betul kan Chan yang tanya saya kan?
Yang hyperbolic madam. Hyperbolic tu saya try masa chapter 1.
Yang guna case ni, second order homogeneous linear, kalau guna yang you need to find root, M1 not equal to M2 tu, case 1, if you turn to page 35, Okay, if you turn to page 35, you need to refer to the given table under section 2.2, and then you can see that case 1, your type of root. If you get root M1, okay, not equal to M2, so it can be two types of general solution, whether in exponential or cosh and sin. So doesn't matter whatever A and B or M1 and M2, you just plug in what the values you get, and then you will get the answer. So let's say for example M1 and M2 interchange between these two values pun doesn't matter, sebab nanti we will recheck for the answer as long as your steps correct, so you will get more marks on your steps, not only the answer. Okay, boleh tak Chan? Chan ke? Kalau tak salah saya Chan yang tanya saya.
Tanya tentang apa, madam?
Bukan Chan yang tanya saya about page 35. For example, case 1 and case of your roots.
Rasa saya yang tanya kau. Boleh.
Siapa? Chong Oh, Chong.
Ya.
Sorry lah, tertukar. That's why
Boleh.
Chan blur. So clear Alright. Sorry Chan, sebut nama you pula. Okay. We can continue for the next chapter. Chapter 3. Log out pula dah. Sekejap saya punya tab ni pula lah tak boleh connect internet. Connect tapi I tak boleh masukkan password. Okay. Kelas, I pun tak tahulah what happened. You tengok ni. I tak boleh nak, tak ada keypad pun keluar. Tak boleh nak enter any letter.
Madam dah try restart.
Belum, sekejap give me time sekejap I restart dulu. Okay. Okay, kelas Alright. Okay, Bismillahirrahmanirrahim. So, kelas. Saya record sekejap. Saya rasa pen saya ni rosak ni ke? Sekejap Okay. Okay, class. Today we continue with chapter 3, which is system for first order linear differential equation. Okay, again, chapter 1, we had covered for first order differential equation. Chapter 2, second order. Okay, and then now chapter 3, we look at system of this first order. Okay. So, at the end of this topic, students should be able, you should be able to solve homogeneous system for first order, and then linear differential equation through finding eigenvalues and corresponding eigenvectors. Okay, and then the second one, solve non-homogeneous system for first order using method undetermined coefficient, and then perform. If you still remember, undetermined coefficient is the method that we have learned previously. And then the third one, perform system of first order linear differential equation using maths tool. So maths tool, so that this is about your project. And then perform good teamwork in solving system will be covered in your project. Okay, class, here. Previously, we know about methods for solving first order and second order. Okay, now we will look at about the system. How to solve if we have a system. Okay, so most of ODE systems will consist of at least 2 linear ODE into unknown functions, which is y1 and y2. So if we have y1 and then we find out that it has y2, so it is called a system, linear system. Linear or not, we need to know what is the criteria to be linear or non-linear. So that, for example, here, okay, we have y1 prime and y2 prime. Okay, in y1 prime, it has y1 and then y2. Y2 also has y1 and y2. Okay, so because y1 and y2 is differential equation, so differential equation that has consists of at least 2 ODE or 2 unknown, so this called a system. So this also has y1 and y2, so it is a system. It can be up to yn lah, plus y until yn. Okay, it depends. So similarly, a linear system of n first order ODE is n unknown functions, okay, or is in form of, okay, function in form of, okay, like this. Okay, a function we don't know what is the name of the function. So the function being represented as y1 prime, y2 prime, and so on. But in the function or the system here, it has y1, y2 up to yn, and then plus gx. Right? So here, simply as linear first order system, how do we know it is linear? Again, this question you have learned since chapter 1. How do we know this is linear? Linear depending on ingat tak? Prime to the power of 1. Okay. So linear. So we assume that the coefficient a, I, j as well as the function g and x are the continuous in common interval. Okay, here equation or a system that can be represented in form of y prime equal to ay plus g. Okay, and then this is a system. This is a system. So you can separate, okay, it's a, y, and also g using matrix form. Okay. So here y prime equal to ay plus g. So y prime is actually y1. For example, it has matrix y2 prime equal to matrix A, and then y1, y2 plus g1, g2, for example. It can be like this. Okay. So in definition 3.1, the constant or variable coefficient from 2 times 2 matrix A that has an array. So here matrix A can be 2 times 2. Okay, and then it has you should know which one is your A11, A12, A21, A22. Okay. The idea I will explain later. So similarly, coefficient from n times n matrix. So it can be more than 2 times 2 matrix. Okay. So in a linear, a linear differential system is called homogeneous system if G equal to 0, meaning that this G equal to 0 so that Y prime equal to AY. So this is homogeneous. Okay. So if it has value of G, this become non-homogeneous. Okay. So this G, So if you can see y1 prime and y2 prime here, okay, y1 and y2, this system is homogeneous because we have y1 and y2. Yes, correct, because in a system we need to have two variables here, independent variables, y1 and y2. But here in this case we don't have G. Okay, so or we call it as G equal to 0, so that this is homogeneous system. And then in this case we have y1, y1 and y2. So this a system, this is a system, but we have values that not attached to any y1 or y2. Okay, this 3n exponential 2x. Okay, so this is your G. So G is not 0. This is a non-homogeneous system. Okay, so for example 3.1. Example 3.1, for each of the following system, determine which is a linear differential system if it is, write in matrix form and determine whether homogeneous and whether it's a constant coefficient. Okay. So for the first one, we are given y1 prime, y2 prime, and y3 prime. So three systems here. Okay, so equation given. Okay, this is A, your A, because based on matrix, you have y prime equal to AY plus G. So in this form, for this y1, y2, y3 prime here, you can rewrite in matrix form. So your y prime is this. So y1 prime, y2 prime, y3 prime. Okay, and then A, after that you have y kan, y1, y2, y3 plus G. Okay. Right, so based on this, okay, y1, so here is A1, 1 minus x. Okay, here y1 kan, y1 is 3, and then here no y1, so 0. Okay. And then next for y2, exponential x. y2 here is x. y2 here no y2, so 0. And then y3, for y3 you have sine x. After that cos x. And then y3 here is 1. That is what you get for your A matrix. Matrix A. Okay. Then look at your G. Anything, any number that not attached to any y. So here for y1, y1, so 1, and then for y2, you have x exponential to x, and then y3, no G here, 0. Okay, so far do you have any problem to create your own matrix? Anyone still confused? So this is G, this A, this is Y, this is Y prime. Okay, so your G not equal to 0. So since G not equal to 0, this system is non-homogeneous. Okay, and since A is not a constant of function, this system is not a constant coefficient linear differential equation. Okay, because this is not constant coefficient, not constant, because it has in form of x. Okay, for B, get B. So for B, okay, you have y1 prime, y2 prime equal to your A. A is matrix A, y1, matrix A, you have y1, y2 plus G. Look at your G. So y1 here, A, and then negative C. Okay, B. For y2, by1. So you cannot create like this. Cannot. Okay. So this system is not linear differential system because the presence of the product of y1 and y2. Okay. So that you cannot solve for this. Okay. Right. So we look at example 3.2 here. Example 3.1, 3.2. Okay. Given that a system that consists of two first order linear differential equation. Okay. And then the question, show that y1 x, okay, the value is given, the equation is given for y1 and also y2, okay, is the solution for the system. Okay, you are given by this. Okay, the question give you y1 prime and y2 prime, but at the same time, okay, you need to check whether, okay, based on the given value y1 and y2 in this in the question will be the solution for this system. Okay, y1 and y2 given, but you need to recheck. So the first thing you need to do is, okay, based on y1 and y2 here, because we want to check whether y1 and y2 here will be the solution for the differential for the ODE, the given ODE. So you need to differentiate y1. So differentiate y1, you will get -2, and then differentiate y2, you will get -4. So this is solution from y1 and y2. Okay. So that from y1 and y2, you need to find y1 prime and y2 prime. Okay. And then here is the process for you to check. Check and meaning that you compare. Compare with the given ODE. Okay. So y1 prime equal to 3y1 minus y2 plus 2x. Okay, here is the equation given in the question. This is given. So that you need to use the given value y1 here, y1 here, -2x plus 1, and then y2, -4x plus 5. Okay. Substitute the given value y1 and y2 into the given ODE in the question. So you will get -2. Okay, because it is a very simple math, so I don't want to go into detail. So again, for y2 prime here, okay, substitute y1 and y2, and you will get -4. So that class, from here you need to check your y1 prime here, that you substitute your y1 and y2, is this is similar to your y1 and y1 prime that you find out yourself based on the given y1. Okay. So same goes to this. This is y2 prime, -4. You need to check, is that same or not? Okay. If same, so that you need to conclude y1x and y2x is the solution of the system. Any question? Okay. Now we try to go exercise 3A, try for A. Okay, and then B here, it has typo, so never mind, try A first. I give you tak sampai 5 minit ni. 3 minutes. Okey, dapat tak? Okey, boleh solve eh?
Boleh, madam.
Ada yang tak dapat tak? Otherwise saya tak nak tunjuk lah. Kalau kata tak, semua dapat, saya tak perlu tunjuk lagi lah. Perlu ke? Okay, since semua tak ada jawapan, so saya tak perlu tunjuk jalan kerjanya. So for B here, ada sedikit typo. If you look at this equation, okay, in this part, right, it has no y1 and y2. It's actually, please make correction for this. Here is y1, y2. This is y1 plus y2. Okay. Betul kan, Okay. And then you may try. So now, I want to go for homogeneous system, right? Chapter 3. System of first order linear differential equations. So in this chapter, right, you should know two types or types, two cases actually, for the system. The first one, if the system is homogeneous, okay, homogeneous system of first order LDE, linear differential equation, and then the second one for non-homogeneous system of first order LDE, linear differential equation. Okay. So today we will look at for the first one, homogeneous. So in this homogeneous system, it has three cases. Okay. The first one, okay, if your eigenvalue, okay, your eigenvalue real and different eigenvalues. What does it mean by real and different eigenvalues? Eigenvalues here, you need to look at your lambda. Lambda 1 not equal to lambda 2. Okay. Not equal to until how many lambda? Up to lambda n. Anyway, depends how many lambda you need to find. The second one, if you have same and repeated eigenvalues, which is your lambda 1 equal to lambda 2 equal to lambda until lambda n. And the third case, complex number. So complex meaning that your lambda or eigenvalue can be informed in alpha and beta, real and imaginary. So for this part, okay, steps for non-homogeneous, the step the first one, you need to write your system in Y prime equal to AY plus G form. Okay. Number two, you need to find your eigenvalues. Okay. Meaning that lambda 1, lambda 2, okay, dot. Depends how many lambdas. And then you need to find eigenvectors. Okay. Number 3, okay, you need to check whether it is linearly independent or not.
Doktor nak tanya,
Ya?
ni homogeneous kan?
Saya dah tulis.
Ah, ah.
Allahu Akbar. Makasih. Banyak makan kuih raya ni. Terima kasih Tadi betulkan saya Aisyah Thank you. Ya kot Aisyah. Alright. You need to check for linearly independent. Linearly independent, sometimes I'm using LI Okay. So, linearly independent, you need to check based on V11, V12, V12, V21 here. V22. If your class eigen, this is eigen vectors. Okay. If this value is not equal to 0, so this is called as linearly independent. If not equal to 0, linearly independent. If this equal to 0, is not linearly independent. Okay. And then number 4, you need to find general solution. So general solution can be written in 2 forms. The first one is A V1 exponential lambda 1x plus B V2 exponential lambda 2x, or you can use y small yx equal to A. Here is your eigen vector exponential lambda 1x plus B V21 V22 exponential lambda 2x. And then you need to find out particular solution if applicable. Okay, before that, I would like to test about your understanding on matrix form. For example, if you have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, class. How can you determine your A11, A12, A13, for example, A21, A22, A23, okay? And then A31, A32, A33. Okay. Which one is your A11? 1, 2, 3, 4, 5, 6, 7, 8, or 9?
1.
Number
A12?
2.
4.
4.
2 or 4? Who vote for 2? Raise up your hands, class. Lagi. 10 second. 10,
number 4.
9, 8. Sabar, saya tanya for who vote for 2 first. 10 second, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, 22 students. Who vote for number 4? Sekejap. Okay. I give you 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. 6 students. Other than that? Other students, how about you? Other students? Now total 28 baru. This class supposed to 39, about 40 39. Tak nampak. Okay. You should start with A, row and column. Okay. This part we call it row or column? This. Row or column? 1, 2, 3 here. Here. Row or column? Class?
Oh, doktor.
Here is row. This is column. Macam ni ke?
Row is horizontal, vertical is column.
Here is column. Tu mana satu? Yang ni pun saya nak tengok berapa ramai based on your understanding. I want to check for your fundamental here. Who vote for black one? Here is row, here is column. I give you 10 second. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 16, 18. Who vote for the red color? 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 12. Okay, class. Right. So, I got worry, quite worry because most of you choose for incorrect one. This part is column. Column 1, column 2, column 3. The answer is, mana this will be the answer. So column here is column 1, column 2, column 3. Here is row 1, row 2, row 3. Most of you answer, okay, for the other way. Okay. Okay. This is not the answer. Answer is column and row. So based on row and column, okay. So here will be your A11. Here is A. Look at your row. 1, 2. Here is A1, 3. Betul tak? Siapa bagi love tu? You tahu tak? Saya buat salah ni. Siapa betul ke salah ni? Ha?
Bet-
Horizontal.
Betul kan doktor?
Betul ke salah?
Yang merah tu saya rasa betul doktor. Rasa.
Row, column. So A11. Merah tu betul kan?
Betul.
So that class. Alright. Row column ke column row? Row column kan?
Row column.
Okay. So that class, please nanti you mungkin kejap. Row column. So here. So the answer A12 will be 2 or 4.
2.
Mana saya punya pen? The answer is 2. Okay. So kat sini macam you confuse here, but you still get correct answer. So please stick in your mind. It starts with row and then column. So here become A, row number 2, 1, A22, A23, A. Okay. Right. So class, kat mana tadi kita? So homogeneous So to solve the system, 3 cases. I've just simplified. Okay. And then below are the steps. Okay, class. I hope you will not confuse your matrix A with V here. This is eigenvectors. Eigenvectors. Because here V11 is supposed to be V12 here, right? Okay. But this is different things because this you get this based on eigenvectors that, never mind, you will, I hope that you will not confuse because you need to go for few steps and then you just take this value. Okay, it's not about matrix like A matrix, so this is different. So please, this only what can I say here, this is the way that you just need to substitute V1 and V2 directly. So this is V1, this is V2. Okay, please do not confuse with 1112 to 122 here. Right. Okay, maybe we can look at example 3.3 here. So solve the following system of first order, okay, linear differential equation. So class, you have y1 prime equal to 3y1 plus 2y2. And then y2 prime equal to 4y1 plus 5y2. So the first step is you need to write in matrix form. Okay. It's supposed to have, by default, it's supposed to have plus g. However, based on the given system here, there is no g, meaning that your g equal to 0. That's why the equation only, or the matrix only consists of y prime equal to ay. Okay. So that this is quite simple actually. You start with, this is y prime equal to your a, just use the number that attached to y1. Here y1. Okay, here is y1. Okay. And then this is for y2. So for y2, this part is for y2. Okay. Okay, class. Let me ask you. So now we have, in the question we have 3 and then apa? Example 3.3. 3, 4, 2, 5, right? And then we have y1 and y2. So the matrix here is matrix M cross N. Okay, M cross N. So here, what is your M and what is your N? Matrix 2 times 2. Doesn't this not a big problem for you because row and column, okay, both is 2. So for y1 and y2 here is matrix 1 times 2 or 2 times 1? Who vote for A and who vote for B? For A, 1 times 2. Who vote for B, 2 times 1? Lapan belas, 19. Yang lain, how about other students? Okay, this is 2 times 1. Okay, one more thing that you need to check. If you have 2 times 2 and then you multiply with 1 times 2, it cannot be happen. Okay, this is very, very basic if you multiply 2 times 2 with matrix 2 times 1, you will get matrix 2 times 1. Okay. So, this very fundamental about matrix that you need to know. Okay. Alright. And then you can also write in form of this, because we know already this y is about y prime and this y is about your y. So this is of course your matrix A. So step number 2, you need to find the eigenvalues and corresponding eigenvectors. Okay class, if you refer to maybe other reference book, sometimes it uses in form of phi. In engineering maths 2, if not mistaken, it uses phi. Okay. Okay. So find eigenvalues and corresponding eigenvectors of A. Okay, class. How can you get this? We where this equation 3 minus lambda, 2, 4, and 5 minus lambda come from? This is based on, okay, it is come from A minus lambda I. Okay. Meaning that your matrix A berapa tadi? 3, 2, 4, 5 minus lambda that multiply with identity. Identity is 1, 0, 0, 1. Okay. So that you will get 3, 2, 4, 5 minus lambda 0, 0, lambda. So that's why 3 minus lambda. Okay. 2 minus 0. 4 minus 0. 5 minus lambda. That's why you will get 3 minus lambda, 2, 4, 5 minus lambda. Okay. Equal to 0. Okay, now, if you solve for this, okay, you will get, if you use calculator, we call it a root, okay, but this symbol we use not no more using M1 or M2, so we use lambda. So lambda in this course we call it as eigenvalue. So eigenvalue, you will get 1 and 7. You can interchange these two, so not a big deal for this value. So in this case, it uses 1. Okay, for lambda 1 equal to 1. Right? So if you use lambda equal to 1, you need to substitute the value here. Your lambda equal to 1. So you will get 3 minus 1 equal to 2. You will get 2, 2, 4, 4. Okay, xy, okay, equal to 0. So you multiply for this, okay, and then here with y plus equal to 0. And then for x plus 4y equal to 0. Okay. Here explanation. Okay. The system of equation has infinite solution from either the first or second equation. So we obtain y equal to negative x. Right? How can we get y equal to negative x? You solve either one. So you will get y equal to negative x. Okay. Let x equal to s. So as you change x equal to s, so y become, when you change x equal to s, you will get y equal to negative s, because just now you have y equal to negative x here. So now become y equal to negative x, negative s, and the corresponding eigenvector is in form of matrix x, y, and then x equal to s based on this, and then y equal to negative s. Or you can also write in form of this. Okay. But class, if you want to stick, if you want to use y equal to s, so you will get different answer. Okay. So because the relation between x and y, okay, x and y, okay, the relation between x and y is y equal to negative x. Okay. So based on this, if you start with x equal to negative y, you also can use this. And then after that, you want to change your y equal to s. And then your x become negative s. So the answer will be negative 1 and 1s. Never mind, you can choose whether you want to use x or y to be your s. Boleh? Sampai sini. So for x equal to 7, the same thing, the same step. So you will get these two equations. Okay. Meaning that here you will get negative 4 multiply x and then plus 2 multiply with y equal to 0. And then after that, you solve for this row to get this. Okay. Here, based on this, your y equal to, okay, so it uses this one. Y equal to 4x over 2, so that y equal to 2x. Now, this part, it choose x equal to s, so your y become 2s. Okay, so y become 2s, so that you have x and y. Okay, have s, okay, y equal to x equal to 1. So y equal to 2s. Like that. Okay. But if you choose your y become your s, okay, so you will get this x equal to 1 over 2s. Okay. The same thing, y equal to 2x. Now become s. So s equal to 2x. X equal to s over 2. Right? You can use either one. So when you have x and y, this become s. S. So y equal to, so x equal to 1 over 2s, 1 over 2, and then y equal to your y equal to s, 1s. Okay tak yang up to here?
Okey, Doktor.
Okay, since s is an arbitrary constant, we can assume s a certain value. For example, 0, 1, 2, etc. Throughout this chapter, we will assume s equal to 1. So, the simplest one is by assume s equal to 1 except indicated s are the value. If the question not not mention what is your s, whether 1, 2, 3, so you are suggested to use s equal to 1. So and then step number 3, check whether the corresponding eigenvectors are linearly independent or not. So here, what you need to do is, okay, just now you have lambda 1 and lambda 2. Based on lambda 1, you will get v eigenvector 1, and here you will get eigenvector 2. So here v1 1, v1 row. Nanti confuse pula . But in this case, it uses v row column. Never mind. So here v, it uses v21 and v22. This is actually I really worry if you confuse here now for this part. What you can do is what you have for v1 and v2, you just use that value in the matrix. So in this case, it uses, for example, so this, kalau based on this example, 1, -1, the first choice, the first one, 1, -1, 3.3, 1, -1. It choose this and this. So just take the value 1, -1, and then 1, 2 here. So this become your bigger matrix. Right? And then you, so for this matrix, 2 minus -1 become 3. So here, this matrix or this eigenvector not equal to 0. So this is linearly independent when it is linearly independent, you need to write its general solution based on this format. Okay, so V1 here, straight away use V1 and V2. Okay, here is lambda 1 equal to 1, lambda 2 equal to 7. Just substitute the value. Okay. Or you can also use this form. Y1 is A, here is Y1. And then Y2, this part for Y2. I think it's not very complicated, but sometimes it can confuse you due to matrix. Okay. So for example above, eigenvalues are real and different. Therefore, corresponding eigenvectors are linearly independent. However, in case problem has the same or repeated eigenvalues, usually its corresponding eigenvectors not linearly independent, meaning that your eigenvalues for case number 2, okay, so normally not linearly independent, meaning that your matrix step number 3 equal to 0. Okay, step 3 equal to 0. So in this case, we need to follow the procedures as below. It has another procedure, but class before we go to this procedure, I want to give you another example for you to try. Okay, for eigen values, real and different eigen values, so that you can try okay, this example. Y1 prime equal to 4. Ini soalan ni apa? 3 sama pula. Sekejap. Actually, I have few examples here. Okay. Maybe we may try. Quite similar, but I hope you can have general idea to solve for case number 1, 3y1 plus 3y2. Okay. Because after that you will get eigenvector in fraction. So you may try this. I give you 5 minutes to try this. Step number 1, y equal to ay plus g. Try. First step dapat.
Dapat.
Ini quite simple So, step number 2, lambda and eigenvector. So, lambda 1 dapat berapa?
6.
Lambda 2?
1. 1 dengan 6.
1 and 6 So, tak kisahlah which one. So, step. Okay. I just write it here. Tak boleh macam ni So, matrix A. So, you will get 4 minus lambda 2, 3, 3 minus lambda equal to 0. So, 4 minus lambda, 3 minus lambda, minus 6 equal to 0. So, you will get lambda 1 equal to 6, lambda 2 equal to 1. Then next, for eigenvector, so yeah, I need to see first. Okay. For lambda 1 equal to 6. Okay. Okay. This is something that I maybe I can share with you the idea here. Okay. Just now for eigen value, you need to use a minus lambda I equal to 0. So for eigenvector actually, a minus lambda I, you need to multiply with V. Okay. So that, alright. So berapa you dapat eigenvector? What is your eigenvector?
S negative S.
S. Meaning that 1 negative 1 S. Macam gini. Macam ni ke? Any other answer? Or lambda 1 equal to 6. Was still negative? Are you sure? Ada any other answer? Okay, mind we try together.
Saya dapat dua-dua positif je.
I got both positive.
Let us do it. So 4 minus lambda, 3, 2, 3 minus lambda. Okay. For this, we have settled for this part. Mak dah tak ada. Okay. Times V here is your, for example, XY here. Go to 0. Meaning that 0. So 4 minus 6. 2, 3, 3 minus 6. So XY go to 0. So you will get negative 2, 2, 3, negative 3. Okay, XY. So the equation here, negative 2 multiply with X, negative 2X. And then plus this multiply with Y. Plus 2Y equal to 0 also. The second, and then the second 3 minus 3, so 3x plus, so plus negative 3y, so become negative 3y go to 0. You can choose anyone. So let's say if we want to use this become 2x equal to 2y, x equal to y. For this, 3x equal to 3y, x equal to y. You can use anyone, you will get the same answer as equal to y. So let's say that x equal to s. So y equal to s. Okay. So for eigenvector, okay, say V1. So you will have in form of s. So here is x, y here. Okay. 1, 1, s. Okay. So the answer is the second one. This one you need to recheck for your plus minus operation here. Then lambda 2 equal to 1. So 4 minus 1, 2, 3, 3 minus 1. So 1 here is lambda. Okay. And then x, y equal to 0. So you will get 3, 3, 2, 2. X, y equal to 0. So berapa you dapat? For S, eigenvector, what is your answer?
1 negative 3/2.
Any other answer? Ada, okay. So 3x plus 2y equal to 0. Both sama Plus 2y equal to 0. So x equal to negative 3x equal to negative 2y. X equal to negative 2y over 3. So let x equal to s. Okay, y equal to negative 3s over 2. So eigenvector. Siapa pening lagi kat sini? V2 equal to. So s x. Wait. xy. S. So s x equal to 1s. So 1s. Y equal to negative 3 over 2s. Okay. If you have any question, you may interrupt. Okay, next. Step number 3. Check for Li. Linearly independent or not. So how to check for this? So you use, here you just put V1 and V2. V1 just now. V1 is 1, 1. V2 is 1 negative 3 over 2. 1, 1, 1 negative 3 over 2. Okay. So apply this. So negative 3 over 2 minus 1 equal to berapa dapat? What is your answer here? Negative?
5/2.
Negative 5 over 2.
5/2.
So here is not equal to 0. So this is linearly independent or not? This is linearly independent. Okay. So since this is linearly independent, how to solve? You need to use step for general solution, right? So general solution, what is the general solution? Okay. So AV1. Okay, use this general solution, or you can write like this. Okay. So you have yx equal to a exponential lambda 1x plus b lambda 2 x. So the value here is v1. Here v1, here v2. v1 is 1, 1. v2 is 1 negative 3 over 2. Dapat tak? So lambda 1 is 6, lambda 2 is 1. Okay. Okay, so we cannot go further step because initial condition not given. So we cannot get what is A and B for particular solution. So we just stop here. I give you 10 seconds if you have any question. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, class. So we stop here. Class dismiss here. So see you for section 8. See you. Kita mula lambat sikit dalam 2 suku. Quarter past 2 eh. Alright, thanks everyone. Bye.
Thank you, Doktor.
Terima kasih, Doktor.
Welcome.
Thank you, Doctor.
Okay, Doktor.
Thank you,
Thank you, Doktor.
Thank you, Doctor.
Thank you, Doctor.